the mean value theorem. It's not mean like angry mean. It's mean like the mean you learned back in the day, like mean, median, and mode mean. So mean back in the day meant average. So the mean value theorem is kind of like saying the average. It's the middle, the mean, the average. So the mean value theorem is going to create a connection with the derivative and the slope of the secant. That's what the mean value theorem does. So the best way to really understand it and to see it is to apply it visually. So we're going to start with like the formal definition, which says the mean value theorem allows us to take a continuous closed interval. This time though, EBT was good with continuous and closed. MVT adds another condition. MVT must be differentiable. MVT must be differentiable. So MVT says continuous, closed, and differentiable. Now, it does not have to be differentiable at the endpoints. So if something has like a sharp corner on an end, doesn't matter, as long as the endpoint is differentiable around it. So like you could look at an absolute value, but like snap it at the vertex, and that VT would still apply. So if it is continuous, closed, and differentiable, so it has 3 conditions before you can even use this. So it has to have these 3 conditions: continuous, closed, differentiable. Then you are guaranteed that the derivative at a point C is equal to the slope or the average of those values at some point. So this is kind of a fancy way of saying the slope of the tangent must equal the slope of the secant at some time. The slope of the tangent must equal the slope of the secant, meaning the slope of the tangent and the slope of the secant are parallel to each other at the endpoints and at C. So the equation of the tangent line will be parallel to the slope of the secant line at that point C. You are guaranteed that C exists if the yellow highlights are true. You are guaranteed that. So you'll see the word guaranteed a lot. Like in the multiple choice word problems, they'll be like, are you guaranteed that point C exists given blank and blank? And you need to know yes or no. They might not, they might tell you in a sneaky way that it's twice differentiable. Differentiability implies what? Continuity. So they might not put the words continuous in there. You have to know and remember differentiability implies continuity. So they may not put the word continuous, but if they put differentiable, you need to know it implies continuous. So let's visualize exactly what's happening. So we're going to start with the function. So we're going to start over here. We have this little graph of f of x. And on f of x, we have 2 points. We have A and we have B. So what is the label or the name of these 2 points? If this right here is A on the line f of x, how would we label that if I just said, hey, label those points? Yes. It's going to just be A, f of A. So then the higher point would be So step 1 complete. In the figure to the right, label the indicated orders pairs. Label a line segment whose length is f of b minus f of a. Label a segment whose length is b minus a. So f of b minus f of a would represent the height of like a mini triangle in this problem. So this would be the segment AB, and the green would be the segment f of b minus f of a. The quotient would then be f of b minus f of a, and that would represent what? You do f of b minus f of a over b minus a. It's kind of like a fancy way of doing y2 minus y1 or x2 minus x1. So what does that represent? Well, yes, a fancy one is slope of the secant, but in terms of this problem, it just represents the slope. Represents the slope between 2 points. So if I join those 2 points, so I'm going to join the point A, f of A, and B, f of B. I'm going to complete my little triangle. I'm going to join my 2 points. That would give you an equation of a line that goes through those 2 points. Now, let's talk about C. C is some unknown value that lives on F. So right now, C could technically be anywhere. C could be here. C could be there. C could be there. We don't know where C lives. What we want to do is predict where C lives such that C gives the slope of the tangent to the curve. So f prime of C is going to give the slope of the tangent line to the curve. And that should make sense. You take the derivative of f of x and you plug in C, that represents the slope of the tangent line. Represents the derivative at that point. So what would the point be? That point would be C apples.
Molly Sheets and Riley Seibert, please come to the office. Molly Sheets and Riley Seibert, please come to the office.
So the graph above, locate the C value that you think would give a line parallel to the blue line. So you want to try to pick a point on that graph such that wherever you pick it, it's going to give you a parallel line. So you want to look at this curve and you want to be like, okay, I think C lives right here. And again, that's my prediction, because I feel like if I draw a line there, it's pretty parallel to the curve. Because if I drew a line down here, I'll turn off the button for a second, that's not going to be parallel to the blue line. So you remember, your tangent line is following the slope of this graph. And as you get higher, it's not going to be parallel. So for me, kind of in here looks to be about parallel. So that's what I was doing. I was taking my, and kind of trying to pick the parallel point. So the 2 line drawings on this graph are, what word have I been saying 100 times? Parallel. 2 lines drawn on this graph are parallel to each other. Thus, the conclusion of the mean value theorem can be restated as there will be two parallel lines, one through the blue points and the other through the red point. Make sense? That is the mean value theorem visually. That is what it means. So as we go through and we talk about the mean value theorem and we use it and we apply it, that is what you are saying. You are saying, hey, I have 2 points on a graph. I have a third point on that equation that's going to give me parallel lines. Remember when you thought parallel lines were like a thing of the past? Nope, they're back. So these are kind of like the most basic definitions of it. I'm just reiterating and restating. This is another way to say what the mean value theorem is. So it has to be continuous on a closed, differentiable on an open, and that guarantees a number exists. This is the most basic form, but like anything in calc, we can have alternate forms. So this is kind of like the standard form. The alternate form is that the change in y is equal to the slope in the change in x. So change in y is equal to the slope times change in x. And it just might be a way you have to see it. So if you want to put this on the front next to your other stuff, you want to take a picture. It's not in your packet, it's just sort of like added detail. So what's the best way to do a problem? To practice doing a problem. To understand mean value theorem, we're going to apply the mean value theorem. So we have f of x equals 5x squared minus 4x plus 3 on a closed interval. What do we know about a quadratic function? Quadratics are always domain and always contiguous. They're polynomials. They don't have any points of concern. So polynomial functions are always continuous and differentiable. So they're not going to give you that information. They're going to rely on your knowledge of a quadratic to understand that. So we know a quadratic is continuous. We know it's differentiable. So we're going to calculate the slope between that closed interval. So in the case of this problem, that f of b and f of a come from the closed interval, which represents AB. So if you don't know where your A and B are, your A and B come from the interval given. A is the first number, B is the second number. So I need to know f of 3 and f of 1. So f of B and f of A come from plugging 3 and 1 into the original function. So I need to take 5 times 3 squared minus 4 times 3 plus 3 and 5 times 1 squared minus 4 times 1 plus 3. So 3 squared is 9. 9 times 5 is 45. 45 plus 3 minus 12. So 45 plus 3 is 48. 48 take away 12 is 36. And then f of 1, you have 5 minus 4 plus 3. So I always like to add all my numbers together and then subtract. But again, the order you do it doesn't matter. You can do 5 minus 4 is 1, 1 plus 3 is 4, or 8 minus 4 is 4. Either way will work. So now I need to calculate f of b minus f of a over b minus a. So I need to calculate my slope. So the slope of the secant is 16. What I want to do is then find the derivative of f of x at c. So instead of finding f prime of x, we're going to find f prime of c. So we're going to change all the x's to a c. So f prime of c is equal to 10c minus 4. And then the mean value theorem says that f prime of c must equal m for some number c. So we're going to say 10c minus 4 equals 16. I'm going to set the derivative equal to the slope of the secant and solve for c. So what that means is that at f prime of 2, the derivative is equal to 16. So if you found f prime of 2, it would be 16. And what that means is that at f prime of 2, or at x equals 2, you will have a line parallel to the average slope. So the average slope is 16. At 2, there is a line that represents the average slope. So it goes all the way back to like kind of driving your car, right? So cruise control is an average velocity. So if you're on the highway and you're cruise controlling at 72 miles per hour, will your car at some point go 72 miles per hour? Yes. Will it probably go 75? Yes. Will you get stuck behind a truck and you got to slam on your brakes and you jump down to 65? Yes. But cruise control is kind of like that slope of the secant. It's your average speed, where the tangent represents your speed at any given instant, which can change depending on the conditions of the roads. Make sense? Okay, I know how much we love trig. I actually put a trig one on there just because of yesterday's trig awfulness. And I was like, we need more trig. So find the equation of the tangent line to the graph of f of x equals blah, blah, blah on the interval 0 to 2. At which point is the solution to the mean value theorem going to occur? So worded different, but the goal is the same. We want to find some point at which the tangent line and the secant line are parallel. So we need f of pi, f of 0. We need the slope of f of pi minus f of 0 over pi minus 0. We need the derivative, and I need to know when the derivative equals the slope. So you kind of need a few things. Now again, think about 2x. Is that continuous and differentiable? Sine, continuous and differentiable? 1. So you can look at a function and think of it as individual functions and check for continuity and differentiability that way as well. I'm tired of blue. So what is f of pi? Well, f of pi is 2 pi plus sine of pi is plus 1. 2 times 0 is sine of 0 is plus 1. So f of pi minus f of 0 is 2 pi plus 1 minus 1 all over 5. It is not a coincidence that 2 pi plus 1 minus 1 cancel the 1s, and then you get 2 pi over pi, which is, what is the derivative of 2x? derivative of sine, derivative of 1. So, slope of the tangent is 2 plus cosine x. Slope of the secant is 2. So what do I got to do? Subtract 2. So what do you get? What is the cosine of x equal to 0? So this is like saying x equals cosine inverse of 0. So 0 is like your unit circle value. X is your unit circle point. It's your radians or degrees, but I like radians. So what radian value gives cosine equal to 0? Perfect. Why don't I want 3 pi halves? That. And it's not in the interval given. If my interval was pi to 2 pi, you actually need 3 pi halves, even though that's not in the actual. That cosine inverse is only for quote unquote inverses. So, because like, if this interval was pi to 2 pi, then you would need 3 pi over 2. Because that would be the true point in that interval. Alright, but in this case, that's the only point in this interval. And then if you turn it on your calculator, I mean, that's only if you Alright, activity 2. We're ready to meet mean value theorem sister, Rule's theorem. So Rule's theorem applies to a particular situation. And that's what we're going to graph. So the particular situation is 2 points on the coordinate plane that have the same y value. So give me 2 points on this plane that have the same y value. I don't care where you draw them. They don't have to be the same as yours. They don't have to be the same as yours. Yours, or yours. So draw any 2 points on that coordinate plane. Just make sure they have the same y value. Or does it stay on the screen? It's my nose. Okay, so 2 points, same y value. Step 2, connect the 2 points with any continuous differentiable function you want. Draw a continuous differentiable function. Every single graph I drew meets those conditions. Every single graph I drew meets those conditions. So if you had some variation that looks like any of those are usually the 4 most common picks. Does anybody something crazy different from what I just any of this for? How many of yours looks like the red one? How many looks like the yellow one? Nobody went upside down? Anybody look like the black one? See, told you. Alright, connect the 2 points with a continuous function that's differentiable. And now let's take our conclusion. Is there a point on your function or my function where you can draw a tangent line that is horizontal to the slope of your endpoints? So what is the slope of my endpoints? Let's name them like we did before. If this is A, f of A, then this is b, quote unquote, f of b. But what do we know about the slope if b and a are at the same height? 0. So the slope of the secant line of f of b minus f of a, if b and a are at the same height, is always a 0. So if you drew one that looks like the black line, what do you know about the extremas slopes? Oh. So do you meet the conclusion? You drew it like the U-shaped red one. What do you know about that point? Its slope is, because it changed from increasing to decreasing. If you had my green line, you just connected them straight across, that's like y equals 2. What's the derivative of y equals 2? So Rolle's theorem says that if you have 2 points on a graph and they're at the same height, the slope of that secant is 0. It's guaranteeing you that you have an extrema. It's guaranteeing that you have an extreme value. It's guaranteeing you have a critical point. Rolle's theorem is another way of finding a critical point and or finding your horizontal tangents. So if you get asked about, does this function have a horizontal tangent, and you have 2 points that are at the same height, then you could prove it, that it does. So the history of Rolle's theorem, basically it says you have these 2 points on the x-axis that are at the same height on the y-axis. Our function's differentiable, our function's continuous, meaning no breaks, no holes. That means that there is a derivative everywhere along that function. What he said was that there's a tangent line that will be horizontal. So he was like, hey, I'm going to take mean value theorem, I'm going to make my own theorem, I'm going to name it after my last name, and I'm going to use 0 as my particular condition. So continuous and differentiable are still the same. You have to have continuity, you have to have differentiability, you have to have a closed interval. What's unique is that the closed interval heights must be the same now. So the new idea is that the heights must be the same now. The height of B and A must be the same. Therefore, it guarantees we have a critical number. It guarantees a critical number. So that's why I think EBT and IBT and MBT get confused all the time. Because EBT guarantees extrema. Rolle's theorem guarantees a critical point with a slope of 0. And that there is another point on the graph where that occurs. So there's lots of like tiny details that go with that. So we have f of x equals x cubed minus 6x squared plus 9x minus 2. It satisfies all 3 of those hypotheses on Rolle's theorem. So what that means is f of 0 and f of 2 must be at the same height. We know it's differentiable. We know it's continuous. Let's prove f of 0 equals f of 2 by finding f of 0 and f of 2. So f of 0, easy breezy, cancel, 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 negative 2. F of 2, not so easy breezy, we gotta cube and square and multiply. So 2 cubed is 8, 2 squared is 4, 4 times 6 is 24, 9 times 2 is 18, minus 2. So 8 and 18 give you 26. Thank you. I was gonna say, look, I have to have a typo. Three cubed plus 9 times 27 is 54, 54 minus 54 is 0. Thank you. Find all values of C that satisfy its condition. So now f of 0 equals f of 3, meaning that my slope is 0 now. So Rolle's theorem is really just a fancy way of saying f prime of C, where C is a critical point, equals 0. So derivative of x cubed is 3x squared. Derivative of 6x squared is 12x. And derivative of 9x is 9. So I want to know when 3c squared minus 12c plus 9 equals 0. So it said find all values of c. So I changed my x's to c's, and then we solve. So 3, 12, and 9 all divide by, so you can make this a simpler quadratic. Somehow I think 12 and 9 are much more difficult looking at than 4 and 3. When you see a negative 4 and a positive 3, you go up. 3, 1, easy. But the 12 and 9, I don't know. Somehow it's less simple to look at. So you get 3c minus 3c minus 1. Therefore, I have two critical numbers, one at 3 and one at 1. So we have 2 points in this interval where the slope of the tangent is equal to the slope of the secant, and that there are horizontal tangents to the graph. So those are both critical points, they're horizontal tangents, and they're points of MPT in technicality. So like, a whole lot of stuff going on. When does the mean value theorem not apply? The mean value theorem does not apply if one of those conditions is not met. So what would happen on this graph? The absolute value of x minus 3 is going to create what? A corner. So what do we know about a corner on a graph? Yeah, because the slope from the left and the slope from the right are not the same. So what you would have to do though, since this has like the 3x on it, you would almost have to create your piecewise where it's 3x minus the absolute value of x minus 3, and 3x plus the absolute value of x minus 3. So you have 3x minus x, which is 2x plus 3. So this is one of your graphs. 3x plus x is 4x minus 3. So again, you could see that one has a slope of 2 and one has a slope of 3. And again, we know that that change, or that vertex-y point, is going to be at 3, which is in my interval. So why does this not work? It does not work because it is not differentiable at x equals 3 due to a corner. So what would have the graph would have is kind of like these two jutty little like points on the graph, where like the slope of one is less steep than the slope of the other. So it doesn't necessarily look like an absolute value as you're used to seeing. It kind of just looks like a graph where the slopes are changing. So not all absolute value graphs end up looking like these. That's kind of something else we have to like comprehend sort of in calculus that's unique from what we've learned in the past too. Okay, g of x is equal to 2 over x plus 2. So looking at g of x, what do we know about the domain of g of x? What happens on g of x? We gotta go back to the beginning of the year and talk about domains and ranges. What do we know about the domain of g just looking at g? Right, its domain is negative infinity, negative 2 to infinity. It is, therefore, it has what at negative 2? What's that point, what's that called? X equals negative 2 gives a vertical asymptote. What do we know about negative 2 then? At negative 2, the graph is what? Yeah, not continuous. If it's not continuous, then it's not. So this fails mean value theorem all over the place. It's not continuous in the closed interval. You could say it's not differentiable in the open interval. So on and so forth. Okay, x to the 2/3. So what happens on this graph? Yep, there's a cusp. And where's my cusp going to be? And 0 is in my interval. So here's the thing, right? Like, if the interval was changed, then you could do it. So that's why it's so important to know where the cusp occurs. So cusp at x equals 0 implies not differentiable at x equals 0, which is in the open interval negative 1/3. Two stationary police cars equipped with radar are 5 miles apart on a highway, as seen in the figure. As a semi-truck passes the first patrol car, its speed is 55 miles per hour. So, at point A, f of A, so to speak, we'll say that this is represented by 0, 55, because that's at the first police officer and the speed. 4 minutes later, so that's my B value. So So B of 4. When the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck did or did not exceed the 55 mile per hour speed limit at some time between the two police cars. So what's the first thing you would think to do? Yeah, find the average speed, right? Find the speed from point A to point B. So you get -5/4. So what does that mean? That means that the truck was slowing down. His average speed was a -1.25 miles per hour. So what that means is he was slowing down. Average speed